you. So welcome to Hangover slot. And the best thing for sobering is a little bit of C and FFI in the context of PHP. So I was already introduced. The only thing which I should add that I am working for the PeoplePass as a lead developer. And that's pretty much it. So let's roll. Well, in the PHP 7.4, we had a lot of exciting features. For example, type properties, preloading, and FFI, foreign function interface. The first two are pretty much self-explanatory, but FFI isn't so. But what is actually FFI? I have a definition here from Wikipedia. A foreign function interface, FFI, is a mechanism by which program written in one programming language can call routines or make use of services written in another. But this is, well, it's the definition from the encyclopedia. The more important question is, what problems does FFI solve? Well, if you, for example, want to reuse code, but which can be already written, this can be, for example, the connector to some database, you probably don't want to write this connector from scratch. Or you simply want to speed up some parts of your code because you realize that there is some programming language in which your code will be much faster. Or you simply want to do something which is not supported in your programming language. This can be, for example, you want to directly access some hardware or do some illegal operations, such as, for example, direct memory manipulation. And you may ask yourself, okay, but we can already do all of this with the help of extensions. And you're certainly right. But there are a few advantages of FFI if we compare it to extensions. The usage is simpler. You're still in the PHP. The maintenance is also easier. You don't need to change your deployment process. And also the portability is rather better. The FFI is more resistant to Zend API changes. And Zend API, this is the layer between extension and PHP itself. Actually, this tends to change every major version of PHP, and there could be situations when you want to move to a new version of PHP, and you simply couldn't, because the extensions which you are using are not yet available or never will be available for the new version of PHP. Of course, FFI has also some limitations, especially if we compare it with extensions. There is no easy way how to modify PHP internals. Well, so you cannot basically create a new Xdebug with FFI. There is some way, but this is very, very complicated. So let's forget it, at least for now. Also, extensions tend to be faster. They're actually made in compiled language. And FFI usually supports one target language. This is not only case in the PHP, but on all other FFIs, for example, in JavaScript or in Python. Very often it's just a C, because the C has at least maintained at least basic application binary interface. So it's kind of makes a sense to actually call just a C code. So let's compare it with extensions. But before that, we should look how to actually use FFI. So I will try to rewrite an ABS function. We already have ABS function in PHP. It's a function which returns the absolute number of provided number. So for -42, it will return 42. It's something extremely simple. You should never use FFI for this, but nevertheless, it's quite a good example. It can boil down just to 2 lines of code if I remove all formatting. There is a static method cdef on FFI class. It has 2 parameters. First is the definition of function in C, and the second one is the library from which we want to call it. In this case, I want to call it from the standard C library, which is available at every Linux system. I will then just call this through the magic method on the created instance of FFI object. One of the biggest issues in almost every FFI is how to actually map the functions from one programming language to another. In the case of FFI in PHP, it's author-decide that the best way will be actually to parse C definitions. So here we can see the definition of ABS function in C, that's the first, and the second is the definition of function in PHP. They are rather similar. After all, PHP is a C-like language. The biggest difference is that in C, the data types are mandatory, at least from the C99. So, usually also want to use more functions, not only one. Fortunately for this, we have a static method load. Again, on the FFI class, this will also create a new instance of FFI object. It has only one argument, and that argument is the path to header files. And then inside that header file with special notation, we will provide the PyStore library. What are the header files? We don't have them in PHP, obviously. They actually contain scene function definition and other declarations, for example, structures and macros. They have two basic usages. First is all call function in C must be defined in advance. So you cannot call some function and then you define it. This is simply not possible. C is rather old language, and in the ancient ages, this wasn't simply possible. Also, it describes a data structure and similar things, and it's usually called it's usually used when we want to call some function from the library. Also, as I already mentioned, in these header files there used to be macro definitions. These macro definitions are expanded by C Preprocessor, and C Processor is basically just a text substitution engine. It's a very powerful thing. The one note is that FFI does not support C Preprocessor directives, so if you actually want to use any header files, you must resolve these definitions by hand, or actually use a C compiler for that and let it resolve this definition for you. The C Preprocessor is extremely powerful. C doesn't have for each loop, but it can be implemented with the help of C Preprocessor. So this actually looks extremely cool, but on the other side, it lowered the clarity of the source code. And for example, PHP source code is full of these macros, and it can be rather hard to find out which macro has been called or which macro will be used. Actually, I have an example from this from the PHP source code, and we will see this later. This actually forced me to buy a proper CID because I want to have some support during the macro resolution. So, and I have to show the usage of FFI on something practical. And that will be a DuckDB database. I actually discovered DuckDB database on the last IPC conference, thanks to Thomas Blay. I hope that I pronounced that name correctly. And I really like that database. It's actually in process SQL OLAP column-based database. It has been written in C++. It has no dependencies. It will build just into one file. And it contains a column vectorized query execution engine. And if I can translate all of this mumbo-jumbo into one sentence, it's the SQLite, but for the data analytics and with Postgres flavor. The main real usage is if you have a very large CVS file, and by large I mean in the gigabytes, and you want to execute some SQL queries on it, the DuckDB is way to go. I also have here a comparison matrix, so you can compare DuckDB very, very easily with the rest of the database. It's in completely different quadrant than a regular multi-purpose databases such as MySQL or Postgres. Well, DuckDB has the bindings for the multiple languages. It has API for Java, C, C++, of course, and others. But regrettably, there is no support for PHP. So this is kind of ideal use case for the FFI and good candidate for some extension development. And what I will actually present here is a simple example, which I took from the DuckDB website. This is a usual approach. If you actually want to use FFI on any library, you usually go to website, find the easiest example which is on that website, and you try to mimic this in FFI. And in this example, we will create the database in memory, insert some data into this database, and query that stored data. It's kind of simple. So I will start with FFI. I have a source code here. It started with the loading of header files. They describe all functions and structures which I will use. I will then create two structures which represent the connection to database and database itself. Then I will open the database. For this, I will use function DuckDB open. And this function has a signature with two input parameters. First is the path to database which we want to open. If we want to open the database in memory, we will simply pass a null. And the second is pointer to database. We can obtain that pointer by using static method addr on the FFI class. After that, I will check the result code if everything is all right. If it isn't, I will throw an exception. Pretty much same goes with the connection method. I also pass a pointer, but this time to connection, and as a first parameter, I will use the database. Well, I was talking about pointers. Unfortunately, if we want to call any C code, we will have to deal with the pointers. Pointer, of course, is something which we don't have in PHP. So don't be afraid if you think that you actually miss something from PHP. The definition is easy, but the real usage can be sometimes very complicated. The pointers are usually one of the reasons why we can make such a mess in C and create unsecure code. So pointer, basically it's a variable that stores memory address of another variable located somewhere in computer memory. They're kind of similar to references, but they're not definitely references. There is a whole chapter about this in PHP documentation, but this is more focused on C developers than on PHP developers. So from the point of PHP developers, it simply doesn't make any sense. From the point of view of C programmers, it explains quite well. Well, issue is that arrays, strings, and sometimes any complex structure are very often in C passed or written as a pointers. Pointers mainly ensure that the data type won't be copied every time when variable enter or leave function. This is a basic definition, please don't quote me on this. In FFI, pointer can be obtained only to C data type. So I will continue. The last time we tried to connect to database, we again check it against the result code. And in this case, we are actually comparing it to enum. Yes, C already has enums. PHP still does not have them, but it will be in PHP 8.1. So it's quite near. I will use a new function, DuckDB query, and this is basically a function which will execute some SQL query. It has 3 parameters. There is a signature of this function. The first is the connection to database, second is the query itself, and the last one, it's the result object, which we have to pass. Or we should provide a null. In this case, we will simply not care what is the result of the query. And on this function, you can see one interesting thing. We don't need to marshal the input string. There is no need for adding into some, wrap it into some special class or something like that. This won't be true for the strings which will be returned for some functions. Okay, so I query the DuckDB. I actually create a table. In this table, there will be two columns. Each of them will be of integer type. Again, I will check the result, and then I try to insert some data. Again, I will check if everything is all right. Then I will create the DuckDB result. This is actually a structure. And what are the structures? Structures, this is, again, a C-specific thing. I can say that they're like an objects, but without any method. So they are basically just objects with some properties. And the structure which I'm trying to create here contains the num of columns, rows, and that data itself in the manner of DuckDB underscore column. This is a little bit interesting, as this is a column-based database. It actually don't store rows, but columns. It's kind of interesting. And there is also an error message. So again, I will try at this moment actually select some data. So a basic select asterisk from integers, simple. I will pass an pointer to the result object. Again, I will check if everything is all right. In this moment, I can, if there is an issue, I can actually check the query result and load the message from it and display it, or pass it into the exception in this case. I will then traverse the result set. I have 2 for loops for it. In this case, we can clearly see that with the C structure, we are working in the same way as with the PHP objects. So we simply access its properties. And we will iterate it over the rows and columns. And we use a special function for this. We will use a function which will obtain the value for us. It's called DuckDB value varchar. This function is actually receiving data as a strings, not as integers. There is also a function which will do this for integers, but I especially want to show you this. Because in this case, the first thing is that I have to convert the return value from the FFIC data object, in which it has been returned to me, to regular PHP string. Then I can work with it. And also, I have to clean the memory, which has been allocated by this function. If I didn't do this, this will probably lead into some memory leaks. And this brings us to one of the biggest problems in FFI. Well, problem. It's actually not a problem. It's the harsh reality. The memory management between PHP and C is rather different. In the case of PHP, we have automatic memory management. We have a garbage collector, resource counting, reference counting. Sorry for that. This is not true in the case of C. In the C, you are on your own. There is a manual memory management. So if any C function actually allocated memory, you have to free it. And if you didn't do this, you will cause a memory leak. So this is the reason why I have so many destroy, disconnect, and close methods. If I didn't provide them and run this code in some loop, after some time, I will simply deplete it all computer memory, and it will crash. So you should be very cautious if you do this. The general rule of thumb is if function create fails array, strings, or structures, you should look for the cleanup function. This is usually in the documentation of your library. So in this case, you should read the manual. At least I recommend it. It's not like in the PHP in which you sometimes randomly using some functions and you simply don't care. This simply won't work in the world of C. Next logical step will be to convert this procedural example into OOP. So basically by creating some OOP wrapper around it. This is useful because we want to hide an implementation and don't expose FFI to someone who actually don't know how this works. And also it allows us to manage the life cycle of FFI with the help of destructors. So if you ever wonder for which you should use destructors in PHP, this is one of the use cases. So about the PHP extension, this will be a little more complicated. There are a few prerequisites which we needed for that. The first is PHP source code. You actually don't need it for compile. Actually, you need it. Sorry for that. Because there are header files, and without them, it simply won't be possible. You also need a C compiler, of course. PHP is written in the C, and or libraries. This depends on the configuration flags which you pass to compile during the compilation. But I guess that you need at least 4 libraries for this, such as, for example, regex engine, etc. And for debugging purpose, the best is GDB and Volgrind. Both of these debugging tools are C debugging tools. GDB is GNU debugger, because we cannot, of course, use Xdebug for developing C extensions. And Volgrind is memory sanitizer, and it's a tool which can find out any memory leaks. So it's kind of useful. It's preferable and much easier to do this under the Linux. So I support it. Every extension development usually begins with generating some basic skeleton. We actually have a skeleton generator for this in the PHP source code. So we call it. It's a simple command, just with a few arguments, and that's pretty much it. What is quite good, it also prepares some basic tests and set up building scripts. So you then need just a few commands. PHP-is, which will prepare the environment. Configure, which will check if you have all dependencies. Then you can compile it with make. And the last step, which is not mandatory, make test. This will simply run a test. And in this case, we actually wrap the API in object from the beginning. The issue is that we can also mimic a procedural style in the PHP extensions, but then we have to stick with resources, because something still have to represent the connection to DuckDB. So in the past, this used to be so-called resources, but they are no longer a preferred way. They are actually deprecated because they had a lot of the issues. So this is the cause why everything will be object-oriented from the beginning. The heart of every extension in PHP is a structure Zend module entry. This structure holds references to some basic methods which will be executed during the module creation or doing every request virtually. The most important for us at this moment is PHP minute. In this function, we can register and declare our objects. The example here is, of course, not complete because there is a lot of the source code. So this is the reason why I just picked some things. So in this case, I am trying to create. Well, I'm adding the support for database class, which is in the namespace DuckDB. So I use actually not a function in its NS class entry, but this is a macro which will be then expanded. It's start to be a little more complicated. And I will simply register it. I will pass a list of the methods. Then I have to provide two basic handlers. One is create object, which is executing doing the class creation. It's not a constructor. This is something special. It's connected with the way how we have to handle the memory, because in our class we also have to have a DuckDB object. And there is a free object. As you can see, the API isn't the same, because there is a create object and there is a free object. So PHP actually lacks clarity even on the source level, which is kind of shame. We will then register the class, and from that moment it's simply available. I mentioned that we have to pass the list of the methods. For this will be automatically populated, and it will be created from the stub file, which is defined actually in PHP. So you need to write at least a little bit of PHP. So this is some kind of it's basically just blank methods, only with their signature. This will be automatically parsed during the compilation, and the array will be created from it, and it will be used in our extension. So the object new, the PHP database object new function, it's probably the most cryptic one. The main purpose of it is to allocate the memory from the wrapper object. This is something very special, because what we actually try to do in our extension is to have a PHP class, and inside its PHP class we want to have a DuckDB structure, which represent actually the object, the database object. So for this we need to do this shenanigans. So it's a lot of the boilerplate code actually, and of course there are a few gotchas. In this case, we actually have to initialize object properties, and we have to do this even if our class does not have any properties, because we never know that somebody will extend our class and add some properties into it. So we must think about this in advance. We will also install provided handlers. Without it, it simply won't work. Then we can finally define our functions, which will be available to PHP ecosystem and to PHP end user. In this case, I will demonstrate this on the constructor. For this, we will use macro PHP method. So as you can see, this does not actually look like a C function definition. We will see later to which this will be expanded. Because as I already mentioned, C had a preprocessor and a rich macro system, which actually change and substitute some strings on the fly. They usually mark it in uppercase, but this is just a matter of your code style. In this case, I will simply extract the DuckDB object from this DuckDB database object. I will do some input parameter validation. In this case, I am expecting just the path to the database which I want to open. This is an optional from my point of view, so you can omit it. This is the z_param optional. And I was talking about the macro expansions. So now we can see what is the real signature of PHP method class name method name. This will simply expand to zim class name method name, and again there is just another macro inside it, so it must be expanded again. So finally, all of the PHP methods which we will add into our extension will have a following signature. So it's a void, zim, class name, method name. Then there is a structure which represents the actual data that are used during the executing of this command. It's marked as a pointer. And then we have a value to which we shall add our return value. So I will open the DuckDB. This is kind of same as in FFI. If anything is wrong, I will simply throw an exception. This is a C, not a C. This is a PHP exception. C does not have any exceptions. So in C, you usually return some code, or you use a goto for the error handling. And the last one is a PHP database object-free function. This will simply, again, extract the stored object from internal class storage. It will close the database. And again, it will call function for internal cleaning. What's kind of funny is if we don't provide this function, it will at the first sight work as it should, but one day it will maybe crash in some situation in which we simply don't presume that it should crash. So very quick comparison with FFI. So in extension for virtualize this code, we need so many methods, and also we have to know how actually PHP internally works. So it's kind of complicated. The last thing which I want to show you from the extension is the query method on the connection object. This is a little more complicated. Again, actually didn't mention this. In C, you have to define all use variables in advance. So it's not like in the PHP in which you simply use some variable and it's magically created. It does not work like this in C. So again, I will extract the connection object, and I will allocate the memory for my result object. And now it starts to be very interesting, because when I was preparing this presentation, I just realized that I made a mistake. I actually caused a memory leak. And this memory leak is because after I allocate the memory, I do parameter validation. And if the parameter validation, in this case it's a query, and I validate if it's a string, and if the validation fails, I simply don't have any opportunity to actually free the memory which has been allocated by this emalloc. So I actually cause a memory leak, which will happen only in some situations. Kind of bad. And what is kind of funny, I can use a Volgrind for finding if there are any memory leaks. But Volgrind, it's a dynamic tool, so I actually have to run this code. So I have to simulate this situation in which I will pass a wrong parameter, and then I will know that I am actually leaking my memory. So it can be a madness. I will then register the return instance of result class. This is simply done here. And I will actually do the query. So this is a little bit similar as in the FFI. I will again use a DuckDB query method for this. If there is again some issue, I will throw an exception. In this case, I realize that I want to have my own exception, so this is a specific DuckDB statement exception. So it's not a regular PHP exception, but it's some exception which is actually extended from the PHP exceptions. I will add error message into this. Then I will destroy the result because I don't want to care with it anymore, especially in the case when there was an issue. I have here macro return throughs. This is simply just inform the engine that I raise a PHP exception, and that's pretty much it. There are also a few what ifs because I cannot provide you a full source code. It's kind of long. So there are a few things about which you have to think when you creating the new methods in the PHP extensions. What if, for example, somebody tried to clone your object? How this should react? Does the DuckDB actually support the cloning of objects? Well, hardly, honestly. What to do when we try to serialize our class? This also can be a big issue. The underlying library usually don't support this. They are not PHP libraries. Or, this was extremely funny, you can create your class without calling a constructor in PHP. This is through the reflection. There is a specific method which has been actually added by the author of PHP unit. And the first thing which I did was that I tried to use this method on some of my DuckDB extension methods, and it failed miserably, honestly. So you need to disable that method in reflection, or you need to create your class in a way that they simply don't fail if this happens. So the first thing when I finished my extension, I tried to measure performance because I was really keen on how this is faster. It should be faster, so we will see, honestly. I'm pretty much sure that this is not so readable. Sorry for that, but I will at least describe it. The last red column is actually the FFI with the definition parsing. So it's with the all parsings of header files. The first blue column, it's a benchmark for extension. And the two middle columns, the orange and the green one, are the FFI, but without definition parsing. So we can clearly see that the definition parsing is rather expensive. So if I remove it, you can see that the difference actually isn't so big. And in absolute numbers, it's around 6%. So FFI is roughly 6% slower. What is kind of interesting is that if I wrap FFI in the objects, the performance is still similar to procedural style, which is kind of good, honestly. The definition parsing actually added in this huge number, but this is a fixed overhead. So this won't change when you call FFI multiple times. So this is a fixed price. You can lower the number by removing the function which you actually don't need in the from the header file. So there is the way how to make this more faster. Or you can move the C definitions into preloading. So there is an option how to do this. So I was kind of unhappy because I actually invest a lot of the time into developing the extensions, and I realized that it simply won't help me. So if I want to compare it, you should have a decent knowledge of C in both cases. In the case of PHP, this knowledge should be of course better than in the case of FFI. The kind of issue is that C is very unforgiving. You can shoot yourself in the foot in a very creative way. And there used to be a proverb that in the C you shoot yourself in the foot, and then C will roll out the gun for you. Also, the management of library dependencies can be rather problematic. I can demonstrate this on the case of DuckDB, because you still need to somehow distribute the library. So you will maybe put it into repository, a compiled binary file. This is kind of strange. Or you should force people who want to use it to install it as a package. Then you realize that there are simply no packages of DuckDB for major Linux distributions. So it starts to be messy, and this is in both cases. And it also took me, thanks to this, it took me quite a long time to actually set up the build system for the PHP extension to be actually just able to use the DuckDB. And for advanced debugging, we need to use C tools, and we probably don't have any experience with them. Also, the usage of FFI or extension can be insecure, of course, because FFI can be actually a bigger problem than an eval, because you actually can do everything in FFI. You can have a direct memory access, so you can bypass a lot of the security checks. Same goes for the extensions that are actually written in C. This can be a huge problem. So, in the case of FFI, you no need to compile anything. This is quite good. Just press F5, everything is all right. Also, the cross-platform development is rather easy. When I actually try to port my DuckDB example from Linux to Windows, it was just about changing the extension of library from SO, which is the shared library on Linux, to DLL, library in the Windows, and everything was working perfectly. But this was just for the DuckDB. For another libraries, this can be more complicated. And for some use cases, the performance is actually good enough, because for me, the performance penalty 5%, it's quite good. And this has been actually mentioned in the RFC of FFI, because author actually said that we should call a big chunks of C code, not a smaller one. So in this case, the most time will be actually spent inside the DuckDB, not during the calling of that library. Also, the FFI is easier to use, so maybe you will, as me, have a false sense of mastery of this approach. Well, extensions are faster, but in this case, it was just marginally. But you still have to set up a toolchain and compile PHP. Well, I can say that this is easy, but if you are doing this for the first time, it will take you a few hours. So this can be a problematic. Also, the building system can be a problem. And again, every time when you change something in an extension, there is an extra step of extension compilation. And I cannot stress this enough, you should know how PHP works internally. And if you do anything wrong, usually and with segmentation failure, and you simply don't know what actually happens. And then you will need to use some of the C debuggers and try to actually find out where is the issue. There is also a lot of the boilerplate C code. This is a problem mainly because C is virtually free of all abstractions. So in this case, the people usually roll their own abstractions. Can be also a problem. And one quick reminder, C doesn't have any package manager. It doesn't have any official package manager. So when you want to combine multiple libraries, again, this can be an issue. So, which one is better? Well, it kind of depends on your situation, as usual. If really the preference is must-have, nothing beat the extensions. The question is if it's worth all the fuss. Also, extensions can draw clean boundary, because you maybe have someone in your team who is very profound in C. So he will take charge of this extension, and he will just prepare an API for you, and your PHP programmers will simply don't need to care about it. It will be his responsibility. So for this, it can be rather good. On the other side, I personally would use for one-shot thing FFI. And especially during the prototype phase, in which I can define my API, I can explore the library, I can see what all things this library can provide. Then I can measure the performance, and I can decide if it's worth to actually rewrite it in C, or if not. For my usage of DuckDB, I am pretty much sure that I will stick to FFI, because it simply suffices. It's not the bottleneck for me. So that's it from my side. So if you have any questions, also I have a source code for this. In this source code, there are also a Docker image in which a completely built environment for PHP is set, and it's there also an example in the branch solution, so you can compile it by yourself if you have a Docker, and you can play it with it. So that's definitely everything from my side, and now if you have any questions.
Are there any questions in the room? There are no questions in the chat. I'll check one more time.
You can coach me later. I know that it was maybe too complicated, but I will be there, so we will see.
There's one question.
I have a question about the memory leak that you mentioned on FFI. Do we also need to care about it even if the requests are short-lived, not like a long-running process? Would it be garbage collected if the PHP request ends, or it can still leak memory?
Well, at the end of the request, it should be freed, but this is still not a good approach. And well, you actually never know this. It will be definitely free if we, for example, use FPM and the worker will be killed. In other situations, sometimes not, and it will simply stay there for a quite long time, and this can be an issue. I'm pretty much sure that actually PHP FPM will kill that process if it reaches some maximum memory. but I definitely wouldn't recommend it. Also, you never know when you will try to use FFI in some daemon or in some long-running script, and then definitely the memory leaks will be a big issue. So you should take care about it and clean after yourself. I hope that this suffices.
Any other question? Okay.
So thank you.
Thank you very much. In that case, that's the end of the session. You have a half an hour pause, and yeah, thank you very much.